Hello and welcome to this overview of the Dell Storage vSphere Web Client plugin version 3.0 for FluidFS. My name is Sammy and I am a senior Dell FluidFS system engineer with expertise in the area of NFS storage solutions for VMware. In this video, I will provide a brief explanation about the Dell Fluid File System as a storage solution for vSphere. And next, I will show the vSphere plugin benefits for configuration and management of NFS data stores, fast and massive provisioning of virtual machines, and storage monitoring. From an architectural point of view, the first building block of the solution is a storage array. As an administrator, all you need to decide is how much space out of your total capacity you want to provision to the NAS. We call this the NAS LAN space. The Dell Storage Manager configures the LANs automatically for you, and the FluidFS cluster formats them with the Fluid File System. This process results in the presentation of a NAS pool, which is the net space available for file-level storage. The NAS pool can also be over-provisioned and expanded at a later time when your storage demands grow. We manage the NAS pool through virtual storage containers or NAS volumes. Every NAS volume has its own folder hierarchy and its own rules associated with snapshots, data protection, security, and so on. So all data within a NAS volume is subject to the same management policies. We grant remote access to NAS volume locations by sharing its folders via NFS or SMB through the client network. Data stores in the NAS are extremely flexible because they are independent of the underlying physical media. As data store management in the NAS is based on metadata operations, you can expand or shrink them transparently during production and create or delete them in an instant. NAS volume exports in FluidFS can be mounted by as many ESX hosts as you need, and scaling the environment with more hosts is easy because there are no discovery procedures involved. Let's consider a storage design example for numerous production virtual machines cloned out of a few source templates. We prefer to keep the code templates under the same NAS management domain, so let's create a single NAS volume to store them. But to present template types separately, we can create several folders in that NAS volume, one for each template type, and then export them as data stores. We can also restrict write access on these data stores to protect them from undesired changes. In order to preserve the templates intact, we create additional data stores for the production clones. Our virtual machine provisioning strategy is based on the generation of a full replica of each template in the production data stores and the creation of fast space efficient clones that share data with the replica. In general, we don't expect significant usage growth in these data stores because FluidFS clones consume negligible storage space. Last, we assign additional NAS volumes with SMB shares or NFS exports to leverage FluidFS file-level management features on user files. These are exposed to the clone VMs for home shares, departmental folders, Dropboxes, and similar needs. These files and folders are securely available for users using standard domain access policies, and they can be counted for user or group level quota rules. Let's now explore the features that the vSphere Web Client plugin provides to facilitate the implementation of an NFS storage solution for vSphere based on FluidFS. I will be using the FS8610 NAS appliance in this demo. From the various contexts menu, we can use the All Dell Storage Actions item to operate the plugin. Let's start by adding a data store to this cluster. We can use the plugin to add VMFS and NFS data stores from a single interface. When we choose NFS, the plugin presents the list of FluidFS clusters available in Enterprise Manager. There are two main action types. Either we choose to map an existing export, and then we get a list of the existing exports in the FluidFS cluster NAS volumes, or we create a new NFS data store, which means creating a new NFS export in a new NAS volume or in an existing one. Let's enter a name for that data store. Now, we can create a new volume or use an existing one. If you choose that last option, then we'll get a display of the currently configured NAS volumes in the cluster. For this demo, we will be creating a new volume. By default, it gets the name of the data store prefixed by vol. We need to also enter the size, and then either create a new NAS volume folder or use an existing one. Here, NAS volume folders refer to folders used to categorize NAS volumes in the cluster. I already have a folder for all my data store NAS volumes, so I will place this one together with the others. We will also create a folder inside the NAS volume that will be exported to the ESX hosts, and this is where we define the path relative to the NAS volume route. By default, it gets / and the name of the data store. Then we enter the FluidFS virtual IP or DNS name. Last, we get a configuration summary display. Let's click Finish to launch the process. Back in the host and clusters view, we can see that the data store was successfully created and mounted in both hosts. So the process can be summarized like this. The plugin created a new NAS volume in FluidFS with a corresponding export. It created the ACLs that grant root access to the IPs of the ESX host cluster. And finally, it requested all hosts to mount the data store. Let's now check the virtual machine provisioning options that the plugin offers. For example, we can right-click an ESX host cluster, select all Dell storage actions, and provision virtual machines. There are two main actions that differ in the provisioning method, and we will examine both. The first option, create virtual machine, refers to the creation of one or more replicas or full copies of a source template. The great advantage of using the plugin for this operation is that you can generate multiple customized copies at once. This is a list of all the templates under the cluster from which we choose the source image. Next, we enter a base name and number of copies, and the plugin will use an incremental index as prefix for each. Another cool feature is that the plugin has the creation of VMFS or NFS data stores integrated in the wizard. That's in case you prefer to create a new dedicated data store for your provisioned VMs. I will choose an existing data store in this step. The last step in the wizard allows customization of the resulting VMs. We can customize the names, CPUs, memory, and network connection. Let me go back to the beginning of the wizard to show the second provisioning method, clone virtual machine, which leverages the FluidFS file cloning features to generate a cloned virtual machine that shares data with its parent. This is a fast and space-efficient provisioning method because the process involves mainly metadata operations. This type of clones will not consume any disk space until data is written to their disks. When cloning VMs, we can select either a template or any powered-off virtual machine under the cluster. Next, we enter the base name and the number of clones. We can optionally turn on the VMs when they finish cloning. And if you have customization specs, this is where you can apply them. We select the computing resource that will run the VMs, and fast clones reside in the same data store as their source images. Here is a configuration summary. Let's click Finish to launch the process. We can see gradually the provisioned clones appearing under the cluster. As we saw throughout this demo, implementing a FluidFS-based storage solution for vSphere has been made significantly easier using the plugin. Data stores management is now greatly simplified, and the native FluidFS features that we have been leveraging for vSphere are simply to use and presented inside the vCenter web interface. This completes the demonstration of the Dell vSphere Web Client plugin version 3.0 for FluidFS. I hope you enjoyed this video, and thank you for watching.